We would like to welcome our speaker from Denmark. Vanessa Volz is an AI researcher at modl.ai in Copenhagen, where she works on developing AI-based game development tools for automatic testing and for supporting creativity. And this is what I guess she's going to tell us about today. Thank you for being here, Vanessa.
Yeah, thanks. I'm excited to be here. And you're exactly right. That's what I want to talk about. Specifically, how to establish trust in tools like that. So let me start at the beginning, though. So I work at modl.ai, as Galina mentioned. And as she also said, we do AI-based tools for game development. But then not everyone is very well versed in AI. So there can be a lot of questions around how things are going to be used and how things can be trained and stuff like that. So that is the exact topic that I wanted to talk about. Now, we don't just do automatic testing, we also do generation of puzzle games, and that's going to be my main topic today. And the main idea behind modl.ai is to bring state-of-the-art AI research and make it accessible to game development. So that's why me and a lot of other AI researchers that work at modl.ai, we have a very academic background, and we're trying to put that into practice now. And my main research interests are in evolutionary computation as well as benchmarking and using games as an interesting application. All right, so let's get started. Many of you might recognize these big generative models that have been very successful on Twitter or whatever. There's been a lot of hype around AI methods that generate things such as celebrity faces was a big thing. Now currently it's stable diffusion and stuff like that. And so why not apply these types of models to games? For example, in Candy Crush Saga, and we actually worked with Sahar and King at some point, they have a lot of levels that you could use to as training examples. And why not use machine learning based procedural content generation, or PCGML, to generate levels like that? So it seems like there's a lot of potential. And then let me show you our first attempt. They can generate Candy Crush Saga levels, and they are probably playable, but the structure is very different. So the very first attempt, you can clearly tell there's no very clear intentionality behind it. And you will be happy to know that at some point we did improve our methods and we did figure it out, and we actually were working with customers that were using our generation and win rate prediction tools as a central part of their workflow. So that is great, but at the start, of course, we had a lot of concerns, and that is really the part that I want to talk about. So I'm not going to go through all of the questions we got, but for example, one very common one is how accurate the win rate prediction is actually going to be. So that is a question into the algorithm and with benchmarking, basically. And then there are also questions around what if I do X, Y, and Z. For example, I'm going to add a new piece in my match 3 game. Do I need to retrain the bot, or will it be confused? Or like, what if I do X, what will happen? And my main point is that I think if we can get every stakeholder, so the users, the sales people on both sides, and also us, to understand the algorithms that are behind these applications at a depth that is meaningful to the use case, then we can start generating a bit of trust. So let me get into a little bit of more detail. For example, if we're talking about this puzzle maker, what we call it, the generation and the win rate prediction product that we have, we get a lot of questions, and I've kind of tried to group them into these categories. For example, we get a lot of questions around win rate prediction, and you can see in blue, you might want to know, like to answer this type of question, you might need to know a bit about the generalization results. So how well does this method work on different games, on different levels, with different statistics, for different users. And I'm already, you can like specify the kind of depth that you need to be able to answer this question. You don't need to like go in depth. Sometimes it might be enough to say, hey, it worked on this other game, but me as an AI researcher, I might want to know specifics, why it worked and how it worked. And you have questions like that all over the board. So what exactly is the problem that we might want to address? It's not always clear what win rate prediction even means, or like how you can express accuracy, or what the accuracy means in the context of for the game designer. They might not care about like a consistent band of accuracy. They might just really care about, is it a very low win rate or a very high win rate? And so these types of definitions also don't always align. So there needs to be communication about that as well. And so on. And the fun thing is all of these also interact. So if I'm like choosing a specific algorithm for which I know like I can expect a decent accuracy, then the user might also want to be able to interact with it in a specific way. They might want to be able to set specific types of users that the prediction is for, or they suddenly want to set 5 blockers. And you kind of need to consider these interactions as well as how the user is actually working with the tool, so the user workflow, to be able to understand what even the problem is, how to solve it, and how to communicate what the solution is doing, and then how they can interact with the product. And this kind of leads me to the next point. I specifically said understanding because it's not only the knowledge. The knowledge is already one problem. You might not always have the data to be able to accurately say, like the background knowledge. If you haven't applied it to a puzzle game yet, you might not actually be able to make a good prediction of the performance. But the second part is the communication. And that really is a very interdisciplinary problem. You need to be able to understand where client is coming from, where your salesperson is coming from, where you're coming from, to then be able to generate this understanding, and with that, some trust. And I also did want to stress this is, of course, not just related to game development or that specific field at all. There's a lot of AI-based tools that we interact with. For example, I've been really looking into getting a robot Hoover, but I would like to know whether like it will be able to get into the corners, and I would need to know something about it. I'm not really into mechanical engineering, but I would need to know what is the angle it actually can get into. So I don't need the full depth, but I need some understanding to figure out whether I want this robot Hoover for my flat or no. Okay, so with that, that was my introduction, and I was trying to make the point that the trust is needed to be able to interact with the tool. And I think some of it can be, like, we can make progress towards that via some understanding. And I wanted to list some concrete examples of where I've, both in my academic career and with modl.ai now, we've been running into these issues and how we've tried to tackle them. And that's going to be my main point, I think. And then maybe later we can talk about how these generalize and what to do in the future. So my first point is that games are often used at milestones, at least on general media. That's, if you look for games in the context of AI, the really big stories are usually around really big achievements, right? Like when an AI first beat really good Go players, or when Alpha Star was able to beat Mana in StarCraft. And of course, we do a lot of research on Mario as well. But so there are milestones. And the question is then, if someone approaches with a different game, like that doesn't look like StarCraft or Mario, what can you actually tell them that would make them trust that the AI that we're developing would still be able to run on their game? And that is not really easy, because I think most of the time we also don't know. So what I've been trying to do is develop benchmarks as a tool for answering these kinds of questions, and also doing research in that regard. So now I want to do a bit of definition here. In my head, these are milestone challenges, and benchmarks are different in the sense that we know more about the different test cases. They're usually smaller, and we know which aspect of a challenge they might be evaluating. For example, you might have Mario levels and have an AI run through it, and then you have another Mario level and it has it's deceptive because you have to backtrack to get out of it. So the idea is really to have an understanding of the problem, and then figure out, based on the performance of the algorithm, whether it can do problem type A or problem type B. Of course, the downside to that is that these are very abstract tasks and probably toy problems. So then there's additional questions around how do things scale. And that's where the milestone challenges come back in, right? So these are still obviously important, and they make huge leaps in terms of pushing AI boundaries. And they have the benefit of you can do them at a realistic scale, if you have enough compute at least. But it doesn't necessarily tell you how your bot is going to work on the next patch, or when there's different types of players that you're suddenly playing against. So these kind of, you kind of need both. And then there's a third category, which in AI fields, at least for an AI in games field, there are a lot of competitions as well, which are great for motivation, and they're at least in a scale that most researchers have the resources to tackle. And there's a variety of them, but usually there's also not a very clear understanding of what the type of problem is. So if you win that challenge, you're not going to be the best AI ever, right? Because there's no free lunch. So what is it that we are actually measuring if you win that competition? Right. So while I'm making the case for introducing more benchmarks, because the thing is, there are a lot of competitions, there are a few milestone challenges, and there's not a lot of benchmarks out there, at least as far as I know, not in the games sector. So while I've been specifically working on benchmarks, I do want to caution, because they are not the end-all be-all. Benchmarks are usually not very adaptive, and we are in a very changing field, both in terms of games, but also in terms of AI. So we really need to be careful to not stagnate at a specific type of approach, and then suddenly everyone else can not beat the benchmark, or is really good at things. We also need to figure out how to measure coverage, because if you are in a field of games, it's very difficult to categorize the types of problems that we're actually having when you run an AI on a Mario level, or when you're generating things. Then there have been examples of fields that are overfitting to benchmarks a lot, and then you don't have any idea of how they would work in the real world, because that is just not a concern at that point, right? It's just hitting the mark. And then, of course, the scale is always going to be a problem. So I'm really arguing for diversity in terms of the problems that we're covering in benchmarks, and then also in terms of the things that we use to measure progress in AI. So not using just benchmarks, but also the milestone challenges and the competition. And specifically for publishing, I don't think they should be the sole decision criterion. Of course, novelty is always interesting, promising new approaches. So yeah, they should be used with care and updated regularly to fit what we actually want to measure. Nevertheless, I have this benchmark, and I've been using it for competitions and tutorials and whatnot, and also my PhD thesis. And I wanted to get into a bit more detail about it. So it is based around this one publication that we have that is generating Mario levels. And as you've seen before, we also used it later to create Candy Crush Saga levels. And the idea, the method that is using is generative adversarial networks, or GANs. And in case you haven't heard about that, I'm going to do a quick intro. So GANs are adversarial training networks. You have two networks. One is a generator, that is this evil-looking person over there that is trying to forge whatever artifact you're looking for. In this case, it's a Candy Crush Saga level. So it is generating something, and then the discriminator needs to decide whether it is fake, i.e. generated, or from an original source of levels. If the generator is correct, as it is here in this example, it would get a positive reward, and through that, it would improve at its accuracy at detecting things, like the forging. But then, of course, the generator can use this feedback to also improve the forging. And then later, you take this generator out of the context of this training method and can just use it to go from a random vector, which is used as a source of randomness as input, to generating these artifacts. And what we did with the game benchmark, for at least for one function suite, we have several, is the type of problem we wanted is to go from a search space that is n-dimensional in R to some evaluation function that is also in R, because that's the type of problems you usually solve in evolutionary algorithms. So the part is, so this is the input, which is the random vector. Then you have the generator that I was just talking about that spits out an artifact. In this case, it's a Mario level. And then you evaluate that artifact. And for this, we actually used functions from related work. There's a lot of work on generating Mario levels or other platformers. So we picked 28 different ones. Some actually evaluate things that you can see in the artifact directly, such as the number of Goombas or the number of pipes, how interesting things are visually. And some use a bot to run things. So nice, we have a benchmark, we have lots of different functions. But how do you trust this? You don't really understand what's being measured here. And the first problem is that a lot of these functions are not necessarily very meaningful. They're just because someone was proposing an algorithm and they needed an evaluation function. And usually the excuse is, hey, we're just going to have a designer specify that. But that is not that easy. And of course, it's very obvious once you ask. Like I do usually in guest lectures, I ask the students what their favorite World of Warcraft dungeon is, and no one can agree on an answer. So it's a very difficult problem, probably unsolvable. But at least we have some initiatives now that us, me and a lot of other people, form an interdisciplinary network of researchers with psychologists and human computer interaction specialists, that we're trying to at least come up with approaches to evaluating some of the vague ideas that we want to measure in this case. And then we also are working on systematic analysis of the problem itself and what type of problem it's similar to, and what it's not similar to. I'm not going to get into detail here, but please ask questions later if you're interested in this. And then, of course, you also have bots that you're using for evaluation that you might not be able to completely understand what's happening there either. In the case of our puzzle maker, we used a heuristic bot that you can actually understand what it's doing because it's spilling out its intentions very clearly. But then there are also explainer models that we've also been looking into. Lastly, there are also interesting interactions with the game development cycle, because it wasn't clear at the start for us that at some point the bots might need to fulfill multiple goals in the levels. So we were able to deal with that because the bots were very obviously manually changeable. And then, but really, we were like, how do we trust this game development cycle that we actually want to build what the client is looking for? So I think there's no good solution, at least I don't have one. But what we've been trying to do is embrace the game dev cycle. So be aware that iterations are going to happen, have a training pipeline set up that supports retraining very easily, ideally automatically triggered, and have it modular enough so that if a major change comes in, you can just plug out the one bot that makes assumptions and plug another one in. And so basically, this is an overview of some of the trust questions that I've encountered in my work in model AI and also previously in academia. And the thing that I wanted to show here is it's on different topics, but then also some need different solutions. It can't just be us benchmarking in our little corner. It also has to be interdisciplinary approaches. And a lot of it is also about shared vocabulary and knowing about the application enough to be able to answer questions. And this leads me to my two main conclusions that I've been drawing from the last couple of years, is that understanding algorithms in practical applications at the meaningful depth, right? The understanding, the communication, the different type of topics, and then figuring out at what depth to explain it is really important. I think this can get us further to trusting these types of tools. But the most important bit, it cannot be done alone. It has to be done with the client, with the user, with interdisciplinary approaches. And I'm looking forward to working more on that. And that's it.
All right. Thank you very much, Vanessa. It was really interesting to listen to, and it's kind of fun to work on the game type problems, maybe.
Yeah, for sure.
What about it? So we have one question here, but I hope the audience will ask some more questions. Otherwise, I will. So the question is, interesting to know it's hard to agree on the evaluation. Could you take an example of some evaluation metric and why you chose it?
I mean, I kind of tried to avoid the problem of choosing one. I just chose 28 of them and tried all of them. But I mean, the problem is, at first it's vague in terms of what you want to evaluate. And there's a lot of discussion about fun in video games and what is actually fun. So if you ask people what is fun or what their favorite one is, you get results like the one that I showed, right? No one can agree on their favorite Mario level or their favorite Pokemon or whatever. If you are more explicit about what you want to evaluate, I think you can get closer to it. So something like playability is something that you at least have a chance to dig a little deeper into. So if you have an exhaustive bot or you can guarantee solvability, that in a puzzle game, for example, that is something that you can definitely do and that you can agree on. but it might not necessarily answer questions that the game designer is looking for, right? Because they might be actually looking for, is this interesting, or are people just going to leave? I know it's solvable, but how long does it take for someone to find this? So yeah, there's a lot of complexity in what you're looking for and then how to agree on it.
In terms of, all right, let's see. I'm a little curious about a bit more in technical terms, what kind of algorithms or what kind of tools or what kind of things you use, if you see what I mean, because this was a bit more of a high level talk, I would say. Can you throw it like a little bit more technical information for us here too?
Sure. For the generation, we're actually currently using Markov random fields. So because it was a little easier to interact with them than the GANs that I explained at the start, because it's less of a black box. So Markov random fields work by learning a conditional distribution. So you define a neighborhood. So if my, like, I have blockers around me, what is the probability that I am now an explosive candy, for example? So you learn these types of patterns on examples, and then you try to fill a level optimizing the likelihood that all of these patterns are fulfilled. So then explosive candies would occur inside blockers a lot because that pattern has been seen a lot. And that is an evolutionary algorithm that does the distribution. And yeah, it's just a conditional distribution that is learned based on the examples. And then for win rate prediction, we've mostly used this bot that I've shown that is a heuristic bot. We're working on it's dynamic scripting bot, so it will get rewards based on which rules work best and select the best working rules. And this is actually relatively decent in terms of how close it gets to the human performance. And then we use that as an input together with some information that we get from the actual level, such as the game mode and the number of goals and the number of moves, and put that into a linear model to predict the win rates. So that's a regression model.
Yeah. Thank you very much. That's really interesting. Kind of always good to see what what tools and what algorithms people are sticking with, I would say.